Welcome! In a separate video, I showed how to take catchment areas from a geoJSON file and plot them on a map inside an RShiny app. Now I would like to list out the streets contained within the catchment area. However, that information is not contained within the geoJSON file. Therefore, to get the street names, I will take the shape from the geoJSON file, and using OpenStreetMap tools, I will extract the names of the streets contained within the catchment area. I will then put the street names into a table inside an RShiny app. To extract the street names, I have got 7 stages. I will begin by extracting the polygon coordinates from a geoJSON file using an easy R script. Then I will save the coordinates in a poly file using Notepad++. I will download the PBF file for Scotland from GeoFabric's website. I will install and use Osmosis, a tool provided by OpenStreetMap. Then I use the command prompt in Windows to run one line of code to create an OSM file. The OSM file will contain all information from OpenStreetMap for that catchment area, but I only require the street names. Therefore, I will filter the OSM file, again using Notepad++, to get a list of the street names. And finally, I will upload the street names and display them in a table in RShiny. Now, as you can see, this is not the most straightforward of things to do, so I have put the resources I've used into the video's description. I'm always happy to listen to alternative ideas. I'm just showing you one way which worked for me. After all of that, let's now get started. I'm in RStudio and I've loaded in the geoJSON file which I'm going to use in this project. I demonstrated how to load this file in a separate video, and I will put a link to that video along with a link to the actual data in this video's description. I've given my data the name Academies, and if we look at this geoJSON file, you will see there's a polygon section, and if we click on the down arrow, we can see that there were 14 catchment areas which I plotted in this separate video. In this video, I'm only going to be concerned with retrieving the street names for one of these catchment areas, and I'm just going to use the details under number 1 here. So if I click on the drop down arrow and keep clicking down, eventually I come to a row called coords, which contains the coordinates. And as you can see, there are 158 sets of coordinates. All I want to do is load these coordinates into a text file, and that is very simple to do with 2 lines of R code. Across from the coordinates, if you look, there is this little symbol which looks a bit like a notepad with a green arrow. If we click on that, in the console, a line of code appears. We're going to need that in a moment. So I'm going to go back to my R script, and in my R script I'm going to create a data frame which I will call poly1_coords, and I need to tell it it's a data frame, data.frame, and inside the brackets what I'm going to do is copy the line of code from the console and then just insert that between the brackets. That's going to create my data frame. Now I need to put the data frame into a text file, and to do that all I do is do write.table brackets, the name of the data frame, which is poly1 coords, comma, then file equals, and we need to give our file a name. I have saved all the files for this project so far into a folder on my desktop, and I'm going to put my text file in the same place. You don't need to put your text file there, you just need to know where to retrieve it later, but I like to keep things nice and tidy. So to do that, I'm just going to take one of the other files that is there at the moment, copy as path, paste that in, and then all I need to do is, very importantly, delete out the name of the other file. Please make sure if you do this that you do change the name of the file. You don't want to override your old one. And I will call my new file poly1_chords just to be consistent. And I want it to be a text file, so I do .txt. And because I copied and pasted this in, I have to change all of my backslashes to forward slashes. Now I highlight my 2 lines of code and press run. As you can see on the right hand side in the global environment, I now have a data frame which has 158 observations and 2 variables, which is good. If you clicked on it, you could see the contents of it. Because remember, when we looked at the geoJSON file, it had 158 sets of coordinates, so our file looks good. But importantly, we go back to where we'd saved the file, and as you can see, in my folder on my desktop, I now have a file called poly1_chords.txt. Brilliant. Step 1, done. Now for the next stage, I'm going to go across to Notepad++, but you don't have to use this editor. It's just one that's set up on my computer and I'm familiar with using. In Notepad++, I have opened up the text file which I created, poly1_chords, and now what I need to do is remove the row numbers because they are not required in my poly file. To do that, I go to search and then I click on replace. And in the section that says find what, I put in the double quote marks because we have double quote marks at the rows. Then I do opening bracket, dot, wildcard symbol being the star, close the bracket and then close the double quote mark. Then I click replace all, and as you will see, the row numbers disappear. Now what I need to do is have a look at the format of the poly files that OpenStreetMap require. So I'm going to go to the web and look at examples. Remember, we're using OpenStreetMap, so I've gone to the OpenStreetMap wiki, and in the wiki there's a section relating to Osmosis and the polygon filter file format, and that's what we'll be using in this project. Again, I'll put a link to the website in this video's description, but if I scroll down the page I can get an example of what a poly file should look like. So here there's one called Australia, and it gives a first area, then an end, a second area, then an end, and then an end to the overall file. In my project at the moment, we're only going to bring in one catchment area. So let's go back to Notepad++. I'll close the replace box, and in the top row, rather than Australia, I'm going to put in Aberdeen. Then insert a new row, and I'm just going to call my first area polygon 1. I now need to go down to the end of my text file. And as we saw previously, we need to end because we've got a catchment area. So that's the end to polygon 1. And then we need to type end again because we need to end Aberdeen. I save this file and then I go to File again, and I'm going to now save it as something different. So click Save As. And in the section that comes up, I am going to go to the end and take off the txt, and I'm going to type in poly instead. If you were to click on the Save As Type drop down list, you'll see that poly is not there, but I found that in this example, that doesn't matter. I'm hoping it will hold true in other scenarios as well. But in the meantime, ensuring that I've got a .poly, I'm going to press save. That is our poly file created. So I now move on to the next stage, which is downloading the PBF file from GeoFabric. So I go back to the web. Back on the web, the page that I'm looking for is called download.geofabric.de. And again, I will put this in the video's description. But essentially, once we get to this page, we just go down. And because I'm mapping catchment areas for the city of Aberdeen, which is in Scotland in the UK, we go to Europe and click there. From the list that comes up, I scroll down and I have to choose Great Britain. From the sub-regions, I then click Scotland. And on the page which appears, I just need to go to this item called scotlandlatest.osm.pbf and click on it, and it will download a file for me. Now this sometimes takes a few minutes for the download to work. So click to download. Once the file had finished downloading, I dragged it from my downloads file into my R Projects Academies folder on my desktop. You don't need to move this file. I've just done it to keep things nice and tidy for myself. So long as you can find this file again, you can save it wherever is most suitable for you. Okay, let's have a quick recap as to where we've gotten to. So we've extracted the polygon coordinates from a geoJSON file using an easy R script. We've saved the coordinates in a poly file. We've downloaded the PBF file for Scotland from GeoFabric's website. And now our next stage is to install and use the Osmosis tool provided by OpenStreetMap. So let's get started on that. Back on the web, I've gone to a page on the OpenStreetMap wiki, which refers to the Osmosis tool and provides the latest stable version. I'm on a Windows computer, so I'm going to scroll down this page to where it says how to install Windows, follow the instructions in the quick stall. So if I click on that link, we get our hand held as to how to install this Osmosis tool. So to begin with, it says that we need to have Java to be able to run this tool. I've checked and my computer has Java installed. I then need to download the latest Osmosis runtime zip file. So if I click the link to go to GitHub, once there, all I need to do is click on the file called Osmosis dash, and in my case, the latest version at the time of recording is 0.48.3. So I click on this zip file and it will download. We go back to our instructions and it says to put it somewhere where you can unzip, edit it. For example, your desktop. I am just going to extract the file inside the download section because later on in the instructions we will move this file. So I'm going to click on the file, then click extract all. Where do I want it to be extracted to? I'm happy to keep it in my downloads folder because, as I mentioned, I'm going to move this file in a moment. Again, if you want to put it onto your desktop, feel free to do so. Back in my downloads section, where it has been extracted, I click on the relevant file, which is the one that says File Folder as my type. And I'm going to rename it such that the version number is removed. I am just going to call it Osmosis. Now if we go back to our instructions, it says unzip the downloaded file. We've done. You don't need the outer directory, so you can remove the version number. We've done. Then it says put the directory somewhere appropriate, e.g. programs files x86. So that is where I will now put this file. So I will go to where my operating system is and go to my programs file, it's x86. And I will just drag this file on top of program files x86. You need administrator permission, so that's okay. I'm happy to do that. Move the file. And now when I go to program files, I have an item called Osmosis. We go back to our instructions and it says, finally, you need to get access to Osmosis via the command line. Then it says to create a text file with a BAT extension and gives an example. But I have found that in the latest version of Osmosis, if you go to your file in your program files and click on bin, you'll find there's already an Osmosis BAT file there, so you don't need to recreate it. Now in our instructions, it says to run this file by double clicking on it. So we double click on Osmosis BAT. Now watch, because what will happen is the command prompt will come up, but it'll be so fast you might not really catch what is happening, but we'll press to run it anyway. As you can see, the command prompt is there and disappears. We want the command prompt to stay open, and to do that, we're going to create a shortcut, just like it says on the examples on the Osmosis quick install page. So if we right click on osmosis.bat, then click show more options, then select create shortcut. I will now click on the shortcut and then right click, open properties, and then in front of this section that says target, before I get to the double quote marks, I type in cmd space /k and then click OK. Now when you click the shortcut, the command prompt should stay open. Yay, looks good. We are getting there, I promise you. Now all we need to do is create one line of code to create our OpenStreetMap file. Okay, are we ready? Back on the web, we're going to go to another wiki page relating to Osmosis, and this one refers to example usage. Again, I'll put a link to this page in the video's description. But if you scroll down the page, there is a section which says extract an area based on an Osmosis polygon filter file format file. We are going to do some code similar to this, except for our one, rather than at the start saying read XML, we are going to read PBF. So it's just one line of code that we need to put into the command prompt. Nice and easy. So we go back to our command prompt where it's opened. So we type osmosis space --read, then dash PBF space file equals. Then we go to where we saved our PBF file, and in my case it was on my desktop. In the R Projects Academies, I have the PBF file called scotland-latest.osm.pbf. So if I click on it and right click, do copy as path, back in the command prompt, all I need to do is paste that in. Nice and easy. Now I need to bring in our poly file, and to do that we just do dash dash bounding dash polygon space file equals, and we go to where our poly file is saved, and in my case it's in the same place on my desktop, our projects, academies. If I click on poly1 underscore coords, right click, copy as path, back inside my command prompt, I just paste that in, space, and now we need to tell it where we want the output of this code to be saved to. So I'm going to do dash dash write dash XML space file equals, and I need to tell it where I want to save that file. And I want to save it in the same place as all the other files for this project on my desktop in the Academies folder. So what I'm going to do is I'm going to cheat a bit here and just do Control V to paste back in the file that I had done previously, the poly file. But very importantly, I now need to remember to remove .poly. So if I delete my double quote marks and then delete the word poly, after the dot, I'm going to change it to OSM because that is the type of file output that OpenStreetMap will provide us with. And then remember to put my double quote marks back in. So please make sure you have changed your file name if you've taken this shortcut. Then all I need to do is press return. And the line of code should start working for us. Yay, our code is now finished running and I've got no error messages, so all is looking good. Let's now go back to my Academies file on my desktop. And inside that file, you should see that there is now a file called poly1 underscore coords.osm. So it's all looking good. Let's have another quick recap. In this section, we installed and used the Osmosis tool, and then we used the command prompt to run a line of code to create an OSM file. Now, all we need to do is filter the OSM file and then upload it into RShiny. We're getting there, yay! Back in Notepad++, I have opened up the poly1 coords.osm file, and this file has captured absolutely everything on OpenStreetMap which fell within our catchment area. So if you look down at the bottom here, you will see it actually has over 82,000 lines in the file. We don't need that. All we need is the street names. To extract the street names, we're just going to do a bit of filtering on this file. So to begin with, I will go back up to search, click find, and what I want to find are the streets, and I just need at the moment to find one example of a street. So I type in street and find next. Now that I've found a tag with a street name, what I want to do is I want to copy that row. So Control C. I can see what my tag is. I then go to mark, and where it says find what, I paste in my example tag, my example street tag. And what I want to do is find all of the rows in this file which contain the tag address : street. And I also want to bring in the name of the street. So to do that, where I've got V equals, I delete village centre out from in between the double quote marks, open brackets, dot wildcard or star, close the brackets, and then I click mark all. And what you should do is if you scroll down, you'll probably find someplace you'll find all the lines that had that tag highlighted. Now what I want to do is I want to extract all of these rows into a separate file. So to do that, I then at the side click Copy Marked Text. I go back up to the top of Notepad and create new. And into the new file, I just do Ctrl V to paste in all these tags. I don't want the tag names, I just want the name of the streets. So again, we're going to do some simple filtering. So if we click on Replace, and what do we want to replace? Well, I copy everything before the name of the street, so Ctrl C, and that goes into the Find What box, Ctrl V, and then replace with, I don't put anything into that box. And then I click Replace All. And that gets rid of the starting tags. I also don't need the section, double quote marks, / and then the angled bracket. So Ctrl C to copy that. Paste that into Find What. Replace with, again, nothing. So I click Replace All. Now if I scroll back up to the top of my file, I should see just the names of the streets. Because OpenStreetMap, with the code that we wrote, pulled in everything in our catchment area, it means that if there's a street with, say, 40 houses on it, the street name will appear 40 times. So now we need to remove all our duplicates because we only want the street name to appear once. And to do that, in Notepad++ anyway, all I need to do is click on Edit, Line Operations, and then I just need to select Remove Duplicate Lines. And there we have it. Our street names are now only shown once. I will close my Replace box and do File, Save As. And I will call my new file poly1_streets. I will leave it as a text file. I'm happy with that. And again, it's getting saved in my Academies folder on my desktop. So click Save. Now all we need to do is pull this file into my RShiny app. It may be at this point in the video, you've now got your street names and you're going to use them elsewhere. If that's the case, thank you ever so much for watching this video this far. I know it's been quite an involved video. There's an awful lot of stages to go through to get to this point. If you know of any better ways to do this, I'm always open to suggestions in the video's comments. Otherwise, for those continuing on with me, please let's go back to our RShiny app. So back in RShiny, I've opened up the app which I created in a separate video relating to school catchment areas. So please feel free to check out that video if you want to follow along with me in this section. So what I will now do is into the Add Packages, I'm going to add the package DT to render a data table. So it's library bracket DT. To bring in my new text file, I will set up a data frame, which I'm just going to call poly1_streets. And I need to feed into that a read.dlim brackets. And then all I need to do is put in the name of my file. And I can do this because my app is in the same folder as my poly file. So double quote marks and then the name of my file, which was poly1_streets.txt. That's the one we have just created in Notepad++ a few minutes ago. Now I need to set up my data table. So to keep it simple, in the UI section in my main panel, I am just going to type in DT, 2 colons. I want to make sure I use the data table package for this table and that no other table packages override what I'm looking for here. And then I type in data table output and give my table a name. I'm going to call my table just poly1. After my closing quote marks and my bracket, I need to put a comma. And then down in the server section, underneath the curly bracket in the bracket relating to render leaflet, I need to type in output, $, and then the name of my table, which we just put in. We called it poly1. So poly1. And into poly1, I need to feed, still using the DT package, so DT, 2 colons. Then I type in render data table, brackets, then the name of our data source, which if we go back up, remember that up here we called our data poly1 underscore streets. So that's what we put in down here. So back down, after render data table, we put in poly1 underscore streets, comma, and then I'm going to put in a few more bits of code that I typically put into a table. You don't have to put this in, but I'm going to put in extensions equals, and I like to put in buttons. I will do a separate video on what these all mean. So after buttons, a comma, options equals list, bracket, and then I put in DOM equals BLFR tip, and then I like to put in a comma and put in buttons, which will be a list, so it's C, and the list of buttons I will have is copy, CSV, Excel, PDF and print. Okay, so this is what my code ends up looking like for my data table. I've just realised that when I brought in my data file, I forgot to say that there was no header to the file. So let's go back up to the gather data section under poly1 streets. After the text file closing double quote marks, let's do a comma and then put in header equals false. Now I can run my app. Yay, it looks good. My app has loaded and my table has loaded. My table has come through with a default heading of V1, so I can write more code and change it to something a bit more appropriate. But all my street names are there in a nice table. We can see that we've got 73 entries. Just scroll up a bit more, 73 entries. And I have the ability to copy them, etc. So it all looks good to me. Thank you very much for watching this video. If you liked it, please click the thumbs up button. And if you'd like to hear more from me, please click the subscribe button. Thanks for watching.